Alright, this is our final video for Engineering 270, and the topic of this video is networking. It's the last chapter in the textbook, and it's a total of 3 pages. So give it a read, and you'll learn more about networking in other computer science courses, maybe some engineering courses. You can take a university level course on networking. We also talk about some aspects of networking in CSE 223 because we actually develop networked code. But the main thing I want to just hit on in here is this idea of this 7-layer hierarchy of networking functions. And the idea is that at the top here, the application layer, these are things like, a client-server model. So a web browser talking to a web page server, sharing information back and forth. Below that is something called a presentation layer, session, transport, network, data link, and at the bottom is a physical layer. The physical layer is easy to understand. This is the actual, engineering/physics that allows you to send information from one point to another. So it could be a protocol for different voltage levels, meaning ones and zeros. Or it could be an infrared transmitter receiver that generates a pulse at 2 different frequencies to convey different values of information. It could be a physical cable you plug into a wall. It could be a phone line that you plug into the wall. It could be a radio transmitter receiver pair that you use for Wi-Fi. But the aspects of this physical layer are hidden from these upper layers. For example, you don't need a different web browser just because now you're using Wi-Fi instead of a coax cable. So the application layer talks to the layer below it, the presentation layer talks to the layer above and below it, and these lower level layers can be modified, updated, changed without affecting the upper level ones, and vice versa. So 2 layers in particular that are interesting. The transport layer uses something called TCP, Transmission Control Protocol, and network layer uses something called IP, or Internet Protocol. And there's some homework questions that ask you to look up RFC 791 and 793. So RFC is a request for comments. It's the way that when a system is being developed, the public can be made aware of it and shown what the proposal is, and the public can comment on it, make recommendations, suggestions, and so on and so forth. So you can Google RFC 791, RFC 793, and 791 looks like this. So this was made 4 decades ago, 1981. There was no hyperlinking at the time. It was all just printed on a typewriter, but we have hyperlinks here. So TCP talks about IP talks about that network layer, and it's basically responsible for in this simple hierarchy, the lowest level communication. It's responsible for how do we send information from one logical address to another. Right, so if we have 2 machines and we give them an IP address, how do we send information from one to the other? What do we have to put in the message that we send so that it can be delivered to the destination machine? The transport layer is built on top of that and says, okay, now that we have the way to send information from one machine to another, what do we do with that to allow us to do reliable communication, to be able to ensure that our message has been sent, to take a long message, break it into pieces, and ensure that on the receiving end those pieces are put back together in the right order. So the transport layer, TCP, is for reliable communication, and so on. So if we look at this IP document, we can find an internet header. And the most interesting pieces here are source address and destination address, 32 bits each. This is why we had a 32-bit IP address. This is why we ran out of address space, over a decade ago. So, but various flags, identification. checksum for the header, so that if there's an error in any of these bits, we have a good chance of noticing that. Options, padding, and then there's a data payload that's put on here. And software that sends an IP packet will construct one of these things, and the receiving end that receives the IP packet will take it apart and figure out where this packet should be sent to. Now, what do we send in this packet? Well, we want to send data, but we don't want to just take, a 4 million byte message and tack it onto the end of this. We want to be able to break it up in pieces. So, so we use RFC 793. That's the Transmission Control Protocol, TCP. That sits here in this transport layer, layer 4. And the transport layer lets us do more nuanced communication. So here's what a TCP packet looks like. And it begins with a pair of ports, a source port and a destination port. So if you've done CSE 223, these are what we call socket numbers. And it basically says, okay, I know you're going to this machine, but what part of this machine do you want to send this message to? What part of the sending machine is it coming from? And for example, port 25 is something that that we use for mail delivery. Port 22 is something we use for secure logins, a secure shell connection. 23 is an insecure shell called Telnet, and so on. So again, there's a checksum in here, there's some padding, there's a data payload, and so this sits inside an IP packet. The IP packet gets it to the right machine. This gets it to the right port, the right particular server running on your machine, for example. So you can take a look at these. You definitely don't need to read them, line for line, but just kind of look through, get an idea. Marvel at the degree of ASCII art that was used, because graphics wasn't really a thing, computer graphics. But here's a pretty good attempt at breaking down 4 levels of this hierarchy. That's pretty much all we're going to say about networking. Like I say, go ahead and look in the book. It's just a few pages. You can read a different description of this. But that's just kind of a high-level overview. And the main thing to take away is this idea of having a hierarchy of capabilities and functions, distributing the requirements among these different layers to get this insulation right, so that we can modify, say, the IP level without having to rewrite our web browser, or we can, change our web browser without having to modify the physical layer, come up with a new way to do Wi-Fi, right? So everything has its own set of tasks, and that's a useful concept in general. All right, that's it for our last video. We will talk about this a bit in class. We'll work on some practice problems related to this, and that'll do us for Engineering 270. All right, thanks a lot. Bye.